So, welcome everybody. It's like, oh, thanks for being here and not watching the football match. That's a good thing too. So, go away. Thank you. So this is actually a presentation that I've given a number of times already, but essentially it's about a study I did about 2 years ago now on why ransomware became so popular as an attack vector and why they were targeting so many people. And if you actually take a look at the trends in malware, 2015, 2016 were the peak, and the real wake-up call for our industry and for customers is basically in when WannaCry came along, and it really hit badly, right? So when WannaCry came along, people started to wake up, and ransomware is actually, although it's still very much present, we don't see the kinds of campaigns that we saw before WannaCry. So for those, just one little disclaimer. So one disclaimer: I've never used this to do anything malicious. Okay, this is purely a study. This is purely things I did. It was purely an initiative that I did to actually be able to run some research, run some tests against tools, and see how the tools were basically detecting ransomware and what I could do to avoid those tools, and also to see how you could build dynamic indicators. So this is me. Essentially, that's me nowadays because I'm fucking bored and tired of this industry. People are so full of shit nowadays, including myself. I will admit it. I've been in this play for 30 plus years, and that's why that last picture is me nowadays. It's just I don't find anything really new. I don't find anything surprising, and I'm tired of some things going on. I think some of you know, I run B-Side. I'm one of the directors for B-Sides London. I'm also currently the quote-unquote data protection officer for the IWSA UK chapter. So, like I said, in 2016, there was a massive explosion of ransomware going on, and if you looked at, the campaigns were just exploding and exploding, and I'll show you a little bit more about what I mean by that later. But at the time I was working for a product vendor, and one of the things they were trying to get into was the enterprise detection and response, right? The endpoint detection and response. So looking at how you could actually detect new malicious software without actually having any proper indicators. So I wanted to kind of build something that would allow me to test the rules, to test the rule sets, but also to provide certain tools that we could use to actually demonstrate the capabilities of actually picking things up. So the thing is, this was never released in the public, right? So what I did here, it's never been released in the public. I've never used it in any malicious way, right? I just want to make that clear. This is purely an internal thing, and it was used for testing and building demos. So ransomware, 2016. I mean, everybody was saying this was the year of the ransomware. We had massive amounts of campaigns. Every month we saw more and more campaigns, and it was mostly variants of one or other of the types of ransomware. Towards the end of the year, we even started to see some really weird types of ransomware. But we started to see one really interesting thing is that you could actually buy ransomware as a service on the dark web. So you could actually go out and buy an existing ransomware an existing exploited company and use it to ransomware. So you would get you would get a cut of the ransomware, and the ransomware as a service would get a cut as well. So if you had information to help you exploit a company, you could basically use that information to then go buy your ransomware as a service, which is interesting because how easy and how far are we into this process of actually industrializing things like ransomware, right? And that was one of the things that led me to kind of look into this. So then there was the other aspect. So if you've ever worked for a vendor company, you always get the BS and the crap from sales and marketing saying, oh, we need to be able to show that our product does this and this and that. When we show our product does this and this and that, or when there's a new campaign that comes out, we have to be the first to respond and write some really nice article with a demo. I'm like, yeah, okay. Everybody's doing it. Everybody does it. And the problem was really the sales guys. They were all like, well, we have a lab for demoing malware and things like that, but we need something that we can contain and we can demo at any time whenever we're at a customer site. So the sales engineers were like, oh, give us something. You got two ways to actually handle that in a product in a vendor space. You either build a set of scripts, so you can build a set of PowerShell scripts that simulate the indicators, or you can build some like simple files that simulate the indicators, or you can actually use real ransomware or real viruses and actually run them on your environment. So if you go to trade shows, a lot of the companies that are claiming they're doing all this advanced response, they're usually running real live samples inside a sandbox or inside a closed environment. So one of the things I said, it's actually, some of the research I've been doing, I've found out certain things, and we could actually simulate a simple ransomware, right? So let's look a bit back at 2016, why this was probably the year of ransomware. So I actually, if you pull some of the stats that came out, so Proofpoint did this graph, and if you look at the graph, the graph starts end of 2015, but you see towards the middle of the year, just the curve starts to climb drastically, right? So there's a lot more and more. It's it just massively starts to climb, and we start to see more and more frequent campaigns. And in the same way, if you break that down, what was really interesting is that we started to not see any more malicious URLs, and that's, I think, because the mail systems were actually, and all of your network devices were actually starting to pick up URLs, so they would stop you from going to a drive-by type attack. What we saw more and more of is actually the malicious documents, but the black line is actually malicious JavaScript attachments. So one of the ways that these guys were getting in is they were actually sending zip files with JavaScripts inside, and they were obfuscated in a way that the user would just click on the zip file, double click on the JavaScript, and it would run in WScript, making it happen, and you get the ransomware that will take over the environment. So I think you guys have heard of Xavier Martins, right? So he runs a honeypot. I was actually running a honeypot. He runs an email honeypot. I run an email honeypot. So I contacted him and Xavier, can you confirm some of the stats that I'm seeing over 2016? Because I was seeing some really interesting patterns. And he goes, oh, yeah, okay, what do you need? So he's got a little Splunk instance, and he runs all these stats. So what we saw is that you essentially get weekly campaigns. Right. So these are the campaigns that we kind of saw over the year, and you notice that towards around March it starts to build up. So you start to get these. You'll start with a small spike where they're actually testing the campaign, and then towards the end of the month you get a massive spike, right? And this is almost like a DevOps type of activity. They're kind of sitting there going, okay, let's test this. Let's see what we can get out of it, and they start to improve their methods, and you start to see all these spikes. And these are essentially the same types of ransomware that you're seeing over a few weeks. And if you look at the whole year, we just have that continuous pattern, right? So there's an industrialization of this activity in the ransomware industry, where these guys are actually starting to build campaigns, and they're testing their campaigns, and they're releasing the campaign and getting some effective drag through. So this is the same thing, but targeted a lot more to 1 month. Right, so if you see at the beginning of the month, you've got that testing, and then slowly you get more and more precise on your activities and the number of emails that you're seeing. But this was reoccurring week after week, month after month. So so some of the conclusions that I come up with is because of the scripts, the attacks that you're seeing and the types of emails that we're seeing. It was really an industrialization of the process. They were basically testing, refining their activity, refining their scripts, refining their code, and getting more and more precise. So the other thing that was interesting is that we took apart the attachments that we're seeing. And if you look at the big red one, so this is actually the big red portion of the pie chart is zip files. So in 2016, we started to see less and less of the traditional document attachments, and we started to get more and more zip files. And inside the zip files, you would usually find a JavaScript or a C script. So the rest is basically you've got different versions of Word. So there's a few more. These are zip files as well. There's different types, different formats of zip files. So you've got all of these types of zips, plus then you have Word, which was the second biggest, really, if you take outside of zip. Then Excel, and some mixed octet streams, usually corrupt emails. So what is ransomware really, right? So what do we define as ransomware? Well, if you look at the industry, there's basically, we look at ransomware as variants, right? So this is a chart from F-Secure, but I really like it because it again demonstrates the expansion of ransomwares in 2016, right? So if you look at 2016 is here. So if we look at 2016 here, you kind of see that before 2016 and 2015, there's a very few variants. So variants are different types of, and I'll explain in a bit more detail what a variant is. But you've got less in 2015 and you've got more and more in 2016. Right. So 2016, it's just a complete explosion. And a lot of them are very similar to each other. They might have different names, but they'll all usually monthly, they'll be based on a certain campaign. And we got some familiar ones like, March 2016, we've got Pitaya, Subur. These are all things that we saw repeated over 2016 and then into 2017. So what we tend to see is that you'll find that there's 4 different variants of ransomware. So the first one typically that you'll see is some kind of scripted ransomware, right? So the scripted ransomware is essentially you'll have some kind of command line, a Python script, a PHP script, and even PowerShell, right? You can actually do a full ransomware just by using PowerShell. What's interesting with these types of methods is that you're using tools that get flagged as green by most malware detection systems, right? So when you actually downloading this ransomware, you get a PHP interpreter. So if you look at this command line here, right? So if you've seen this, if you've used command line tools, you might recognize that command line. That command line is actually 7-zip. Right? So basically for this campaign, what they did is they took 7-zip, recompiled it a bit, but it still looks like 7-zip, renamed it, and we're just basically zipping the files. And that's a piece of ransomware, right? It's when you think about the fluff that we've put onto ransomware, where it's all this, like the WannaCry attacked, the SMB stack and everything, and then it encrypted, or you encrypted the header. You don't need that much. You just can do it with a simple 7-zip utility that archives the files with a password. The second type is essentially you're using a compile script and you're using some kind of simple hashing mechanism. So you're using base64, RC4, SHA-1, and Blowfish. So this type of ransomware is actually quite simple. And essentially what happens is that it hashes the files, and you can usually easily decrypt them if you figure out which hash it is. So in these first two types of ransomware, when you hear one of the malware vendors say, "Oh, I've got a script to decrypt your locked up machine," it's because they're usually using one of these types of techniques. Because it's easy to reverse, it's easy to understand or identify the key. If you can get a sample of the script, you can basically get the key that was used to password encrypt the file. The next stage up is actually using proper cryptography. So there you're starting to look at AES, GLOSS, BEST, FreeDES, ROT13, and XOR. And what you're typically seeing there is there's some kind of secret key in the code. It's usually hidden, so it's hard to find. But they're using traditional methods of encryption. This is basically the ransomware that you don't want to have, because it's almost essentially impossible to reverse unless you actually get the key. And there's different types where they'll actually have a key management system in the background, so they'll generate different types of keys. The fourth type is public key cryptography, so usually based on RSA. You don't see many of these actually land as ransomware, mostly because it's really hard to manage public key infrastructure. You need a key management system in the background. You need to be able to generate, essentially, what will happen is you need to have a system that generates your backend private key, gives the endpoint that you want to ransom a public key, and that public key encrypts the data. And then once you pay the ransom, you get the private key to decrypt it. it requires a lot of effort, right? Because you do need to have a system where you can generate keys, store them safely, keep them if you want to get paid as a ransomware author. You can't just do this willy-nilly and just have something that goes out and ransoms a machine. Oops. So then you look at actually how they're going to deliver this encryption technique. Well, simply, it's like a five-stage process. The first is the delivery, which is usually the email or drive-by, something like that. Then you execute a script, or you execute your piece of malware. That malware tries to find what files need to be encrypted. It does the encryption. Then you have an optional phase of spreading. So you might use an exploit and actually try to get to the next machine, or you might use a dropper that lands into a shared folder, and you use that shared folder as your stepping stone for other machines to, when they hook into the shared folder, they run the script as well. And then you get a ransom note, usually. All right, and then your machine's kind of locked out. You need to pay the ransom, or you need to restore backups or whatever. So how do we actually do this? So now we have an idea of what ransomware is. Well, what can we do to actually build one, right? What can we actually obtain and do to do this kind of thing? Well, first, it's a piece of software, right? So you're going to go through a software development lifecycle. But I'm a lazy git, and basically I don't like this shit. This is like program management and project management, all that shit. And, this was supposed to be like a really small, quick project. And don't get me wrong, I've done software development in my past. I love developing software, but having to deal with all this stuff just wasn't the purpose of what I was trying to do. I wanted to do something quick that I could easily distribute, that I could easily get up and running to do my tests. So I switched to a different method, which was basically, I said, okay, I'm going to mind map what I need to do, right? So if I mind map what I need to do, I'll have an idea of the structure that I need. So this is the mind map that I came up with, right? So we talked about the delivery part, right? So in the delivery part, I was like, there's two ways I can go. I can go with a web drive-by, or I can go with an email. And if I go with an email, I can do a JavaScript in a zip, or I can do a Word attachment or an Excel attachment. So what I did is I said, okay, what's the easiest I can do? Well, email, Word attachment. Simple to demo, simple to make execute. I'll use that. So that was my first path. So then you actually get to the encryption aspects, right? So that's all this orange stuff. Let me zoom it in a bit. So how do you start with your encryptor? So first you're going to say, okay, wait a minute. I need a language. I need a programming language. It is a program, so I need a programming language. So, you've got your traditional C++, C hash. I'm like, I don't really want to do that. It's just like, it's really complicated. You have to have all these libraries. You need to do all this stuff. I could just, we know that PHP and Python are used, PowerShell's used, so maybe I'll use one of those. So I said, okay, well, let's just use PHP, and I'll explain why a little bit more in detail, a little bit more why I just chose PHP afterwards. So then you need you need to choose your encryption method. So in your encryption method, you've got different choices. You can do, as I said, some kind of proper encryption like with AES, or you can use some simpler techniques like ROP13 or XOR. I chose XOR for a very specific reason. It's easy. It's easy not to mess up, because if you XOR a string with a string, to reverse it, you just re-XOR that, whatever the result was, with the original string. Or your encryption passphrase. So it's it's easily reversible technique. I'll get into that a bit later, but it's a simple process, and it works. So then you need your code. So that's going to actually encrypt all your files. So first you're going to have to set your key, right? So you set your key, you get that code, then you're going to parse your disk. Now, you don't want to parse the whole disk. Does anybody know why you don't want to parse the whole disk? That's one reason. There's a much more important reason.
You want to decrypt it later.
You want to be able to decrypt it later. But if you parse the whole... Yeah, exactly. If you hit one of the Windows libraries, or if you hit one of the system libraries and you encrypt the system files, you'll do a blue screen, or you crash your environment. And if you crash your environment, you won't get any ransom out of it because it's useless. The other aspect really is time, because the longer it takes you to do that time is that you'll end up being detected faster. So you're going to go through each folder, you're going to build an exclusion list, and then you're going to look for documents. The same thing. This is where it was interesting, because you see different ransomwares handle the documents differently. Some will target very specific subsets of documents. So they look for all the Office type documents, right? They look for doc, text, Excel, zip, and JPEGs and things like that. Some will just like blatantly encrypt everything that's in certain subfolders. I chose to actually look at certain document types because it's a little bit more apparent. Plus, you have the tools on your machine, so you can show that the file has been encrypted. So then you have your actual run environment. So your run environment, you're going to run your script that passes the files, does your encryption, you set a registry for persistence, and you show a message. Now, so I said, okay, this is good, but wait a second. I need something more. And I'll explain why I need something more a little bit later, but I had to get to that green part, right? So this dropper aspect. The dropper aspect is a little bit more different because essentially you've got the script, but how does the client actually get to that script? Or how does that client, the endpoint that you're attacking actually run this script? So you need something to actually drop your ransomware. And that's what you typically see in this environment, because you're going to have to load something. You're either going to have to load your own code, or you're going to have to load a tool to actually do the encryption. And really importantly, build a decryptor. It's really important. Trust me. Come on. So, a little bit about encryption, right? Does anybody recognize the bottom encryption? Yay, Caesar wheel. I think it's probably the second time I've done this that somebody's actually recognized it. So the Caesar wheel was probably one of the first encryption methods that we know of, right? Essentially, you basically had a wheel where you turn the letters and you would encrypt. It was letter substitution, essentially. That actually mathematically evolved into ROT13. ROT13 is essentially the same principle as the Caesar's wheel. You just shift your alphabet by 13 spaces and you encrypt based on that. The middle one is an actual XOR. Essentially, you take your original string, apply a downstream signal, and you get the encrypted message with the downstream signal. If you reapply the downstream signal, you come back to the unencrypted signal. This middle blockchain thing where it says block cipher, that's AES, and the top one is RSA. So an RSA, although it's probably the best type of encryption you can use, again, very complicated because you have to have two separate types of keys, right? So XOR, that's the mathematical representation of XOR. So if you XOR your original data with a 0, you get 0. If you XOR the data with itself, you get 0 again. If you XOR the data with another string, you'll get exactly a reversible string. Basically, essentially, if I do the XOR of A and B with C, then I get A is XOR. I hate math. The conclusion is I hate math, and the reason I chose this is because there's a shitload of sample code on the internet, right? So why make my life complicated? It's like if I can find some really good simple code to use, I'm going to use the simple code. And it was really easy to implement in PHP, which is the language that I chose to actually do this. So you need a working environment. You need something like VMware, as well as some coding tools, such as Notepad++ or Visual Studio. Now, if you've done coding, the IDEs like Visual Studio and stuff like that, they're a fucking pain in the ass. They are really complicated. They load a shitload of libraries. It takes half the fucking computer memory. And when you're doing something very simple that you want to write, you want to test it and you do quick coding and you want to do it in VMware, it's a waste of time. It's a total waste of time. The worst being fucking Eclipse. It's like every time I launch Eclipse, it takes like 10 hours to fucking boot because it's just updating all this shit, right? So I don't want, I was like sitting there going, no, I don't want all this shit. I'm just going to use trusted Notepad++. It does basic code, highlighting. It's simple to use. I don't need anything complicated. Oh, remember to snapshot. Really important. I learned the fucking hard way. This is what happened to my development environment one day. I accidentally double-clicked on the file, and the fucking thing launched. So I lost like a couple of hours' work. Luckily, I used XOR, right? Simple. I could just reverse it with the same passphrase. Well, it works if you actually code XOR properly, and you don't make a mistake when you're coding the XOR function. So I lost a couple of hours because I had to go back to free versions of what I was doing in my snapshots. But I learned the hard way, so I started snapshotting every 5 minutes and cleaning off because it started to get quite heavy. So but my point is choose your tools wisely, right? Because you're going to need those. The snapshotting effect is really good. You also need to be careful because it's got to be something easy to deploy. Why did I select PHP? Well, I started to play with these tools, right? PHP, PowerShell, and Python. The reason I chose, they're very simple, right? I wanted to make this simple. And what I found is that the PowerShell is really great. It would have been really awesome to do because I wouldn't have to deploy anything. I could have just done the script and done the encryption. Problem is, unless you're actually running PowerShell v3 plus all the updates, you actually don't get a lot of the necessary functions that you would look for to actually read files and encrypt files. So, and the base, if you look at a base Windows 7, the PowerShell instance is very basic, right? There's not that much functionality in it. It's PowerShell 1.0 by default. So you'd have to update PowerShell to actually get this to run to get anything done properly. Python, the problem was every time I tried to basically use Python, I ended up having to also drop like 10 DLLs. Now, PHP, that was a little bit better because I could actually start to look at very simple executable, right? And then, of course, there's the Word file to look for delivery. I ignored the zip file because actually zip actually introduces more complex aspects where you need to think about how you're actually going to get the user to click. And I just wanted something very simple to demonstrate a very basic phishing and plus ransomware. So that's how we got to PHP, VMware, and Notepad++. So this is so I used to do a little bit of UML as well. So I kind of broke this down to UML just to make sure that I wasn't missing any steps, especially after the one time I encrypted my machine by accident. And so I set the code, so key, set path, that's where I'm going to start. And then basically I go into a loop, I do a find file, I encrypt the file, rename the file, and I check for more files and I go back. This is really important because this loop actually foils some anti-ransomware techniques, right? Because you'll find that some anti-ransomware rule sets and things like that, they look for file rename and they try to stop the ransomware once you hit the file rename. Problem is your file's already encrypted. So even if you stop the rename, the content is still encrypted. And I've found a few products that failed in that way. So this is the actual code, right? It's very simple. It's PHP. So I set a passphrase. I made sure I put the actual passphrase inside the comments, just because I could forget it. I base 64 encoded it. Simple obfuscation. Stupid. Yeah, I know. You then start to look for your folders, right? So you're going to look for your photos, and then you're going to open each directory, and you're going to go drill down in each directory. I'm ignoring WinNT, boot system, Windows, temp program, app data, application. There's a whole bunch of folders that I ignore to avoid blue screen and death. So then I check see if the file extension of the file is equal to something. So text zip rr0 tar gzip doc .xl, a whole bunch at the end. I open the file and I start the encryption operation. So anybody know PHP here? Do you know what the read does? Why I have... So in PHP, so this read, basically it says read the file pointer for 1024 bytes. Does anybody know why I've only setting to 1024 bytes? And not reading the whole file. Speed and time. So speed and time, if I can do it fast, I get less detected, and also I get more traction. But there's another important part. If I corrupt the header of the file's useless, right? So it's not really encrypted, but it's technically encrypted because you can't use it anymore, right? The whole goal is to stop you from using the file. So I've technically stopped the file from being useful. I've saved time, and I've basically created a encrypted file, and it's fast. The other thing too is that if you have really large files, like JPEGs, very large JPEGs, or if you have certain, like I was talking to an oil and gas company once, some of the large data files that they have can span gigabyte, can be gigabytes. If I only hit the header, I'm saving a lot of time because encrypting a gigabyte file is extremely time consuming and CPU intensive. This just keeps it very simple, very light, and it avoids certain types of detection. So once I close the file, I then rename it. I thought it was rename. So then I rename it at the bottom, right? So I mentioned this earlier, that why did I choose PHP is because it was a simple way to do it and I could drop the PHP interpreter very easily because it's small. If you look at the top window, it's 66K only. But you have to be careful which version you're using. So I started with the latest version. Problem is, as soon as I dropped the interpreter and I tried to run it, I got that error message. You have to have a DLL. I'm like, but I don't want any DLLs. So luckily, PHP has a whole bunch of archives. And you can go way back in time, right? So I started to go back until I found, I think it's version 3 avoided me having to drop any really specific DLLs. So I took version 3 and we got to that. So once I do that, you've got your PHP script and you can actually test it, right? So you can test it. It runs. You don't get much output, which is good. But then your files are basically encrypted, right? So I've got my .crypted. That's good. So, are we ready? Well, we've got a batch file, we've got executable, we've got a script. But we still need a delivery method, right? So, phishing attack. Let's simulate a phishing attack, which is the primary delivery method that we've seen. The simplest method is a Word file or a VB script in Excel. Word file with a VB or DDE, and Excel with a VB or a DDE. So everybody knows what DDE is, right? DDE allows you to basically run CMD straight out of Word or Excel. It's much better, it's much faster, and it gets less detected than scripting, and it doesn't require the disabled scripts. With the new security settings, disabled scripts actually doesn't work that well anymore, but with DDE it actually works pretty well. So this is up here. This is an example of DDE. So basically, when you open your Excel file, the DDE detects that you have a DDE request inside the Excel file, and it tells you, do you want to update the external data? You say yes, and it runs that CMD. Right? If you're a penetration tester, this is a much better way to actually get a footprint than using VB script nowadays. So this is an example of VB script. So I hate VB script, and I was like, oh, do I need to do this? So I found this. So this is actually a piece of Russian. This is a Russian toolkit called Fraudox. So it's really interesting. It basically builds your VB script for your Word file completely, right? And I'll show you what else it does in the demo, but essentially it allows you to not only put in a VB script on open, but it allows you to do it on close. It allows you to put in code that actually removes the VB script from the Word file, so that the actual Word file gets updated, so you don't see anymore, so the VB script disappears. But it also will encrypt the original data in the Word file and make it look like it's encrypted, so that when the code runs, it decrypts the text, so it looks like something's happening. Which was interesting, because this is a really good demonstration of a phishing technique, right? And really useful, because it can help demonstrate that the mechanisms that we do. So I've got my Word file, I've got my DDE line, but it's just the PowerShell that's downloading my PHP script. But where do I put this shit? I'm like, hold on a second. I can get a Linux instance, really small Linux instance, free for a year on AWS. Spin it up on AWS. I looked at the terms and conditions. It's not against the terms and conditions. I'm just hosting a file on a web server. So I spin that up. So VPSs are really useful nowadays, especially if you're like doing demonstrations like this, or you're building something like this, or you're trying to research this stuff, because you can spin up things automatically. So I was in Kuala Lumpur at the first conference 2 weeks ago. Have you guys heard of AWS workspaces? They're really fucking useful. I did a CTF just with my Chromebook and an AWS workspace. So it's fun. I kind of love AWS because you get a lot of shit out of it. You can get a lot of shit done with it. Is that enough? Well, so I dug a little bit more into some of the campaigns. Some of the more advanced campaigns, they actually use exploit techniques to get a foothold and spread and potentially do more than just ransomware your environment. So I was like, oh, wow, if I can add this could be really cool. So I started to look into this. So these are the different types of loaders, right? The common loaders, what you see, right? So you've got Zeus, Stridex, SpyEye, Citadel, Carburetor, Andromeda, Smoke, Gaudex, Kins, Kronos, Diode, and Regan. The most common that we saw really in 2016 was Zeus, Stridex, and Dire. And Dire. Those were the ones that were most active in 2016. Most of them have been taken down now. But what's interesting is if you have access to the dark web and if you have access to certain parties, you can actually get you can actually get these toolkits. But you need to speak Russian. And you have to have an introduction. Because these guys basically work on networking and work on who you know and how you're known. Right? So you have to have a relationship, and you have to have knowledge of, you have to get introduced to get some of the cooler stuff. You get money, it basically up there, you see there's a little red box here, it says, so you can get this toolkit for $3,000. Its latest exploit works on Windows 10, things like that. Luckily, I know, I've got connections, so I asked a friend to ask a friend, and so what I did is I ended up using Gaudex. So this is the Gaudex console. Have any of you seen this before? It's like a full fucking CMS. Like configuration management system. Once you've got that dropper on the machine, it basically registers your machine as an agent, tells you what OS architecture it is, tells you what antivirus it has, tells you when it was installed, when it was last seen, if it's offline, online. That's the last screenshot it takes. You can specify the screenshots. So it'll actually screenshot the machine every few minutes, so you know what's going on the machine. So you can actually look, as an admin, you can actually see if it's a sandbox or if it's a real user. And you've got stats on where the machines are coming from and all that, which was really useful because then I could see when the sales engineers were actually testing and trying the toolkit, right? Once I finally gave it to them for demo purposes. But what's really interesting is once you have these agents registered and they're online, you can send additional commands. So if I needed to do a really deep down demo, or if I really need to do something really deep down, I could actually start basically using this to send a Metasploit toolkit, right? Just dump it, use the command line there. And the best part is this is just a PHP page on your web server. It's as simple as that. That's how they basically do it. The CNC is basically an injected web page on your web server, and that's how they get all this information. So it was really useful because I was getting a lot of data out of this. I was getting URLs. I was getting a vision of how this worked. And they provide you with a toolkit to generate the dropper. And it has really good options, like these ones. Anti-debugging techniques, anti-OD debug, anti-IDA, anti-VMware, anti-VirtualBox. All you have to do is click the checkbox and you're done. And you can generate different mutexes. So every time I could generate basically different versions if I started to get detected or anything like that. Right? So extremely useful. This is how simple, this is how simple it really can be. So what does it look like? So basically this is me opening the phishing email. See, this is the encrypted page. It looks encrypted because of that script generator. I click on the enable function, it gets decrypted. So for the end user, it looks really real, right? He closes the file. Now, nothing really happens. Well, you see, okay, Windows Explorer died. That's actually the exploit kit. But the one good thing is I did it on close, so it takes a while. Now, I introduce a lot of latency here. Does anybody know why I introduce a lot of latency?
Give it time to encrypt.
No.
Not to be detected.
Not to be detected. This is basically the longer that you can draw out your actual attack phase, the more likely you are to avoid sandboxing techniques. A lot of sandboxing techniques, what they do is they look at the behavior and activity after about 1 or 2 minutes, right? So by introducing this type of latency, I've actually built in a kind of anti-detection mechanism, right? So it was the aspect was to generate as much data as I could from the different toolkits that I was using. And you see, so now that ransomware has kicked in, it's actually real quick. Once it kicks in, and you see all the files are encrypted. So it was as simple as that, right? So writing the initial, it's not that hard. Writing the initial encryption program was really simple because I could just basically pull an encryption algorithm off and code off the website. I could just look at it and, adapt it to whatever programming language I was using. The more advanced part and the more challenging was actually that second layer of exploit and delivery methods, right? The advanced techniques that I ended up using. Although it didn't take that long. It took me total time less than 24 hours. Okay? With all the toolkits and everything, if I look at the time it took me to code everything that I did, it took me less than 24 hours to actually build this. Which is interesting because if you look at the stats, 38% of victims actually pay the ransom, right? And further studies actually showed that 59% of people paid personally and only 37% asked their employer to pay, right, of office workers. And I found this really interesting because when I researched these stats after I was doing this, so I was building a whole presentation campaign for my sales team, and I was like, this is really interesting because if users are so afraid to actually go to their employer saying, hey, I'm sorry, but I think I clicked on something wrong and my machine's encrypted, and they're paying for the ransom themselves, there's a problem with what we're doing in the industry as security teams. We're not educating people well enough for them to actually sit down and say, oh, I've made a mistake, I need to go communicate it, right? We're installing an aspect of fear that's stopping people from actually doing the right things and taking the right decisions. So if you think about it, total effort versus benefit in the yes box. And that's how I came to kind of like the conclusion that it is kind of quite simple if to actually build the thing. It's the campaigning that's a little bit more complex, but you have means to do that. So the effort isn't that much for the amount of money that you could potentially get, right? So then one of the other aspects I was looking at was looking at how to use this to test certain endpoint detection tools. So the basic encryption script won't trigger AVs because I'm just using a PHP engine that flags green on all way. If you put it in VirusTotal, it just flags green. Next-gen protection didn't really flag it until I turned on script blocking. And I was talking to a guy that works for that company. I'm like, why don't you block scripts straight away? Oh, we can't block scripts straight away because half of a corporate environment uses AD and they have scripts running. So we don't default block all scripts. I'm like, okay. But by using a script, you can essentially avoid that stuff. The real problem is when you start to introduce those exploit kits. That's when you get detected. But if you know, I mean, we all know that there are ways to modify your code and to actually do polymorphic generation and things like that, so you don't get detected. So we heard a lot about advanced, user endpoint behavior analytics type solutions. What they do is they look for massive file modification patterns over a short period of time. And I introduce latency into that encryption process into the script, and UEBA doesn't detect it anymore. Because just if you manage to randomize the latency between the modifications of each file, you start to kill the pattern that they're looking for, right? So once you kill the pattern that they're looking for, you basically stop them from actually detecting you. The other part was I found that a lot of tools actually flag ransomware based on the extension when the file gets renamed. I was like, okay, that's stupid. It's partially effective, maybe. I was like, okay, fuck this. I can get around this easily. Just randomize the extension. Right? I mean, you don't need to... it's simple math, right? Well, not math, but it's simple logic. So, evolutions. There are none, as you notice. I thought of a few things. Going back to PowerShell, potentially. Looking at actually building not using PHP, but using a dynamic compile script that would actually generate different versions of the tool every time so you wouldn't get detected based on the signatures. Randomizing the encryption, automatically randomizing the extension. But I kind of stopped because this little guy pwned me. Where is he? When I was doing this, he got sick, really sick. Cost a lot of money, and I was like, oh, I better step away from the computer. Step away from the computer. Because you start to think things. Anyway. So that's it. I've got a few minutes to spare for questions if you have any, but thanks for listening to me. Not watching the match. I'm assuming Sweden lost, right?
2-0, I think.
Ooh, could be a France-England final.
Let's do it again. Just back.
You missed.
You built this for the company you were working for.
Yeah.
Did they actually try it against any other vendors' products?
I did. That's one of the things I was doing because I was doing competitive analysis as well. I can't really talk about that.
Do we have to buy you beer or drinks?
You have to get really drunk in a private location.
And the contract expires, right?
Huh?
10 months and you can talk about whatever you want.
Yeah.
So B-sides next year in London.
Potentially, if you buy me beers, but I'm not doing it. I'm not doing it in the presentation.
Gliding talk.
Let me put it this way: there's things that I said about detection in there that applies to basically every vendor that I've tested.
I'm doing some next generation security gateway testing at the moment.
Well, I mean, most of those they use sandboxing techniques, right? So they try to explode the attachments in a sandbox. And if you introduce the latency, if you introduce a whole bunch of other detection mechanisms, you can bypass. I mean, at the end of the day, it's you want to hit the 90%, right? The 10% of the guys that really want to get into your organization, you're never going to detect them. Yeah, they'll get in anyway. I mean, the simple, the switch from VB scripts to DDE was one of the biggest things that happened in 2017, right? We stopped seeing VB script and we started seeing a lot of DDE attacks. Why? Because Office turned off scripting by default, and it's really hard to turn back on now. But DDE, they haven't turned off, because if you turn off DDE, then a lot of companies are going to go, why did you turn off DDE? All of our spreadsheets, our 100 megabyte spreadsheets, go out and query all those databases. You turned it all off. Right? And it's the only problem I found with DDE is it's the length that you can actually, there's certain limitations on what you can put in a string. So you got to be really creative. But it works. It's cool. I think we got 2 or 4 minutes to spare. Break. Thanks, guys.